for 2 minutes. Had some technical problems with Zoom.
Hello, sir. Hello.
How are you doing?
Good. Sir, I want to inform you that I cannot turn on the camera because in here is an electric outage.
Oh, there is no problem.
Okay, thank you so much.
No problem. I wish you have a good internet connection and then to discuss today. Okay, it's better. So it seems like there is only half of us. I think we'll wait for another couple of minutes. How did your school year start, guys?
It's already started, sir.
How's it going?
So far, so good.
Do you usually have the beginning of the classes on the 1st of September or earlier?
Yeah, it's usually in the 1st of September.
Okay.
If I'm not mistaken.
Okay, so you.
Yeah.
So you usually have some vacations during your summer, right?
Yes.
That's nice. Did you like the previous lecture so far? What are your key takeaways from the lecture? It's very interesting to understand. Okay. Seems like it was very interesting, so you had a lot of key takeaways from it. Could you kindly, guys, write down your expectation about this lecture? It's very interesting to understand what do you think about this? What would you like to know? Maybe I would stop more precisely on some topics to give you more overview. It would be very helpful. Hi, new joiners, Fernando, Alexandra.
Hi.
Hi.
Did you like the previous lecture?
Sorry?
Did you like the previous lecture that Ekaterina prepared for you?
Yeah. But it's, yeah.
What was the most insightful part for you? Okay.
Knowing about the plastic usable.
Uh-huh.
Yeah, using like a recycle plastic bag. Yeah.
Okay, that's very interesting.
Mm-hmm.
Plastic recycling is a real big topic right now in the world.
Mm-hmm. Yeah.
Enormous amount of plastic, and it degrades into the microplastic that pollutes environment even more.
Yeah, and I heard some news about cassava. They use the cassava to make a plastic bag. Yeah.
Wow.
Using bio cassava. Yeah. You know the cassava, like cassava, right?
Cassava. What is it? I not.
Organic plastic.
Okay.
Okay.
Organic plastic. Yeah. Organic plant. Usually.
That's very interesting. So it's like the natural based bag that you use. Very ecological one. If you don't really use it like a usual plastic bag and change it constantly. All right. So it seems like the majority of us are here. I think we can slightly start our lecture. Today we're going to talk with you about the climate change mitigations. So basically, I would like to stop on several topics that you can see. This is also a picture of me that you are familiar with. Today we're gonna to focus on 5 areas, and I would like you guys to still write down your expectations in the chat. Maybe I would stop more precisely on some of the topics to describe it, to highlight some new insights for you that might be helpful for your future business or your education. And today we're gonna to talk about 5 things. The first one is, the first part will be dedicated to greenhouse gases itself. What is it? What is the nature of greenhouse gases? Why this is really bad for our planet? Not really bad, but bad in terms of a current situation. And then we will touch the aspect of business, how business cooperate with and interact with those decarbonization things, how business reduce its carbon footprint. And fourthly, we will focus on what might be the value for business, for society, for everyone from decarbonization. And then the most interesting, in my opinion, since I am with a technical background and have a strong interest, we will focus on carbon abatement technologies. We'll look at some of this in more details. Okay. So I suggest to start. Firstly, we will start with greenhouse gases. What is it? I will do like this. Okay, so now we are, as a human being, we are living on the Earth's surface. We breathe air, we use air for a lot of things. This is actually the media that we exist in, and we have to treat it. We have to conserve it from pollution, from heating that might actually disrupt our normal lifetime. Imagine if we will, for example, live in another planet, such as Venera or Mars. There is no unique atmosphere like on Earth. So we don't have those mix of oxygen, carbon dioxide, nitrogen in another atmospheres. For example, in Venera, there are a lot of sulfur oxide, and we physically cannot breathe in on Venera. At the same time, the atmosphere of Venera is really hot. That is why we need to conserve our Earth atmosphere. And yeah, so what is going on right now? Right now, maybe you have heard that there is a real big problem with greenhouse gases. So the gases that actually heats the atmosphere. So what do? They usually store in the atmosphere the concentration increases, and then our atmosphere becomes more hot and more hot. What does it mean? How does it work actually? You probably know that there is a sun above us that give us light, that make our life more easier, more happier, especially in gray days in winter. And the sunlight is actually the combination of wavelength of waves that transmit the energy from sun toward the earth. And there is a physical aspect that the waves might be absorbed by different surfaces, by different substances, etc. So how does this greenhouse gas mechanism work? Sun basically emit lights. Lights go to the earth. From 8 minutes from its start, it achieved the earth surface, approximately 8 minutes. What's next? Some of the light is absorbed by its surface. That is why the wind exists. Maybe you saw sometimes when you see at the asphalt or on the really hot summer day, you see some blur on the asphalt. This is the heating of asphalt that cause the gases movement. So yeah, part of the sunlight is absorbed by the surface. Some of them then reflect back to the atmosphere. And what is going on in atmosphere? In atmosphere, we have a lot of molecules, insane amount of molecules of nitrogen, of oxygen, of carbon dioxide, of water vapor, a lot of molecules. And they all absorb those sunlight waves, light. So depending on the nature of these greenhouse gases, it absorbs more or less, and also they absorb those light, those energy, and then it reflects. So basically, you have that sun give part of it and of its energy into the earth, part of its energy into the atmosphere, and then atmosphere might re-radiate, emitted back those energy, increasing the overall temperature. This is the one point. Another point is that you can see on the bottom picture that last year's the concentration of greenhouse gases increased. So this means that more molecules might absorb those light and re-radiate those light. It means that the overall like energy re-radiated in the atmosphere is increasing as well, and it causes the atmosphere heating. As an example of what is going on with atmosphere, you can see the right-hand side map. This is the map of Greenland and North Pole. Yeah. What do you see here? For approximately 30 years, I would say 60% of ice has been melted. Insane, right? So this is just one particular example of how the ice shield is decreasing. The same thing is going on the South Pole. What do you guys think might be the causes of this ice melting? Any guesses? What is going on when the ice is melting?
The temperature rises.
Sometimes yes, but what is going on with those ice?
The volume of water in the sea is going up.
Exactly. You're right, Fernando. So the volume of water in the global ocean is increasing, and this means that it might cause some floods. Approximately, look at the Russia, yeah? It might cause the floods in Russia, north part, in Canada, in Alaska, in the United States, also everywhere in the world. So this is just one particular aspect of global warming. So another interesting part is that it not only, so the concentration of greenhouse gas is increasing, right? But at the same time, it increases more and more. How does it work? There is a theory that existing and developed by a lot of scientists, and it's more like descriptionary discipline called system theory. Since we live in a very complicated, complex, and interrelated life and world, we can describe it from the position of system theory. And system theory basically describes very complex system like food system, like computer network systems. There is also the particular examples of system. Our society is an example of system that can be described with some characteristical element for every discipline, for every system. Those elements are tipping points, feedback loops. For example, if you're doing something and you're in a system, you have the feedback that somebody tell you, okay, you're doing good or you're doing bad. So you have some information about your actions. There is also a very interesting concept of tipping point when the system behavior changes dramatically. For example, in your computer, when you download the virus or something other thing, imagine your computer is a big system and something insert in it and cause some disruption, some problem with you. So it makes a tipping point after which your computer will ruin. So imagine everything goes smoothly, good, and then just one point and everything breaks down. This is the tipping point when the system behavior changes dramatically. So I would encourage you to understand what is self-reinforcing cycle is. This is like self-reinforcing cycle or positive feedback loop and other names of the same thing. How does it work? Imagine that learning self-reinforcing cycle. So if I enjoy doing something, so I'm enjoying, for example, educating on sustainability, right? And I'm doing this more and more. So I'm practicing here, I'm practicing in my university, and I like the thing that I do. I'm becoming more better and better in this, and I have more joy from it. Another example of self-reinforcing cycle is probably the capitalism thing and how your capital is increasing. Imagine that you have a bank account that gives you discount rate on your investment 5%. So you have $100, you put it in 1 year, you put it into the bank, in 1 year you have $105. So now you can invest $105 and next year it will be even more than $110. Did you guys get how does it work? So it's increasing and increasing and increasing, right? And you're actually completely not doing anything with it. It's just doing it by itself. This is how self-reinforcing cycle works. And I would also encourage you to look at our life from the system point of view. Everywhere in the nature exist feedback loops, exist complicated system, very complicated system, like biodiversity is a big system with food chains, with a lot of parts involved. And as an example of self-reinforcing cycle on our Earth, let's look at the permafrost melting. So what is permafrost? A long time ago, there were ice periods in our Earth, and the Earth from this period is in ice. So the temperature is above zero, everything is in ice, but it might be some organic things inside it. Imagine like dinosaurs, they lived a million years ago, then they died, and organic matters from that stayed after their decomposition, they lay out on the Earth, then the Earth level is increased, we have more Earth, and then it's freeze. So we have the permafrost with a lot of organic components inside. And what is going on? So in this feedback, we start from, let me annotate. Okay, so we start from the sun. Surface temperature is increasing. We have the vegetation period and active layer. Increasing temperature cause the melting of surfaces, right? So you have, for example, in the beginning of century, you have let's say 20 degrees here. At the end of century, you have 25 degrees here. And the end of century, you have probably 10 degrees on this depth level, and you will have 15 here. So it means that a part of this permafrost is melted just in 1 century. What does it mean? When it melts, the organic bacteria, microorganisms, they are activating. So they will freeze and say, okay, we don't really want to do anything. Then the temperature increased and they said, you know what? It's actually pretty good temperature for us. We can do something, right? And they started to eat those organic components that stored in this permafrost from dinosaurs, from other animals. And they started eat and ingest those organic components. And they actually emit CH4, which is methane, a very strong greenhouse gas. And the methane goes back to the atmosphere. Or they emit CO2, carbon dioxide, which actually goes to atmosphere through these earth layers as well. So we have increased amount of CO2, and what CO2 do in its turn? It also increase the concentration of greenhouse gases, and the temperature even go bigger. So at the end of the cycle, we have increased temperature here in the layer, and it means that the cycle might come back to this loop into more powerful way, right? So it increases and increases and increases, and in some time, all the permafrost will be melted. All the CO2 carbon dioxide stored here, all the carbon dioxide stored here will be released, right? So this is how the self-reinforcing cycle works. And actual global warming is a self-reinforcing cycle that becomes more and more severe with years. As a next concept that I would like you to understand is, let's look back and understand what was going on previously, right? There is also, as a human being, we like to study history. We study history in the school, history of our country, history of the world. But let's look at the pretty ancient history, 10,000 years ago, 11,000 years ago, and other things, right? What we have here, this is on the left-hand side, you see the size of world population over the last 12,000 years. And on the right-hand side, you see the carbon dioxide level, carbon dioxide concentration in our world, even like completely 1 million years ago from now. What do we see here? We see that 10,000 years ago, it was approximately 4 million of people on planet Earth, just 4 million people. It's less probably than the population of Jakarta, I guess. Am I right in this? Yes or not?
Yes, you're right.
Okay, well, what is the population of Jakarta? Approximately
13 million, I
15
guess.
million. Wow, that's nice. Okay, so then 10,000 years ago, we have the population 4 times less than the current population of Jakarta. Okay, then what's happening? We have 2,000 years, nothing, 2,000, nothing, 2,000, 2,000. We have actually 10,000 years. We have the 0 year of our century, of our like millennia. It was 190 million people. Okay, it's better. But then what's happening? The population grows steadily, and from the some point, it might be like a tipping point. You see that the system goes completely skyrocket. The population is skyrocketing, and it was approximately, I guess there is approximately 8 billion people it will be by 8 million people by the end of the year. So what is going on here? We have such a big increase in carbon dioxide. What does it mean? This is one thing. Very interesting question. What is the cause of it, right? But then we have what? we have on the right hand side, we have 1 million year of history. And as you can see, the carbon level increases here, decrease here, then increase here. So it seems like it's cyclical. There is one cycle, there is another cycle, another big cycle. They're pretty different, but it seems like it cycles as well. Okay, so by the beginning of our like probably millennia, the carbon level is here. Then it goes back at the same at even more temp. As you can see, it accelerates. And what is going on here? So I would expect that it will be back with some years, right, or doing something like that. But with the vast development of people at this point, so when the people becomes more and more, approximately like 8 billion of people, the carbon level increases up to here, which is insane. This is like, it has never been experienced for a million of years. So it seems like we are going out of this natural cycle, right? Or maybe one position is that we're going out of this cycle, so something supernatural happens, something unusual very for these natural cycles associated with ice melting, with other things. Very interesting question. Another reason for that, it might be that it was one cycle, second cycle, third cycle, and this is probably the 8th cycle of carbon dioxide increase, and the system, the global system of atmosphere increases the tipping point and breaks down sometimes, and we have like the steady increase of carbon dioxide, and maybe the next development will be something like that. Okay, very open question. So we see from the key takeaway from it here, we see the skyrocketing population of the world since like probably 18th century, and we observe also a steady increase of carbon dioxide from the 18th century as well. Maybe there is related somehow. What might be the reasons for that? First of all, what caused the human population growth? In the 18th century, the steam engine was developed, the medicine improved, the economical trade improved. Then we became more mobile, and we started to travel to another continents and other countries and see the world around. So it causes the population growth. And this is a very open question in society. So is this cycle human-induced, or it's supernatural things happening in natural cycle? What do you think, guys? So there are actually two strong positions even in global scientific society. One part told that there is a human-induced, and the people are reason for this carbon dioxide level increase. Another part tells that this is like something supernatural, it's just happening and we cannot influence on it. What do you guys think? It would be very interesting to listen to your like ideas, your opinions. You can write down in the chat or just unmute yourself and tell. I would probably think that, so my opinion, I'm not the real, I don't have real big scientific background, like 50 years of those development, but the thing that I see, and from what I know, this is like the truth somewhere lays in the middle. So it was a natural cycle, but we influence it, and it increases, it reaches out the tipping point, and it breaks out. So we are out of this natural cycle, and we are now just influencing the carbon level increase. So in my opinion, it's both natural cycle breaks and human-induced activity as well. What do you guys think? Let's spend a couple of minutes on discussion. Any ideas? Okay. So probably, do you guys understand this concept, or maybe I just need to take it into more brief consideration? Any voice? Okay. I hope that everything is going well right now. And then we are going to another big part. Another big part of our lecture is about greenhouse gases accounting. So now we understand what is greenhouse gases, the things that actually heats up our atmosphere, right? And we also know that there is a big problem with them because they are heating up the atmosphere. So maybe we can somehow influence on it. And to better influence on it, we need to account them, to calculate their level in the atmosphere, to mitigate them somehow. How can we do this? First of all, I would like to understand and to let you understand what are those greenhouse gases. So the most abundant greenhouse gases are water vapor, methane, carbon dioxide, first of all, yeah, and nitrous oxides. This is the chemical shapes of those molecules: water vapor, methane, carbon dioxide, and nitrous oxide. You see that they are pretty different, with different shapes, geometry, with different elements inside. As a chemist, I would also say that the molecules are not really like strictly bounded. They can shuffle somehow. They can do, for example, carbon dioxide might do something like this, so they vibrate, right? And the vibration spectrum is huge for those molecules. Yeah, so every of those molecules absorb the sunlight, absorb the energy, and it can re-radiate those energy to the atmosphere, heating it up. What does it mean? If you look at those molecules, they are pretty different. So I would assume that they probably have different power. Maybe methane absorb more light and emits more light, and maybe nitrous oxide just absorb a small amount of this light, but it might re-radiate it for 100 and 1000 years, right? Hence, we can describe the intensity about the GWP. What does GWP mean? GWP stands for global warming potential, and this concept was developed to allow the comparison of global warming impacts of different gases. Specifically, this is the measurement of how much energy the emission of one ton of gas will absorb over a given period of time relative to the emission of 1 ton of carbon dioxide. And as you can see here in the table, this is a global warming potential. Usually it works for 20 years and 100 years. For 20 years, we stand for 1 for carbon dioxide, we stand 1 for carbon dioxide in 100 years. But if you see at other greenhouse gases, such as methane, nitrous oxide, and a lot of other chemicals, the global warming potential is really huge and big, and there is a big difference. For methane, for example, we see that for 20 years, it's 84 times more strong than for carbon dioxide. But at the same time, at 100-year horizon, it's just 28 times more. For example, nitrous oxides, they're pretty the same for 20 years, for 100 years, and it depends on half-life cycle. So it means, for example, you have 100 molecules. In 12 and 40 years, there will be only 50 molecules of methane. So half of these molecules will decompose. This is how those things works. And what we can say, we have okay numbers for carbon dioxide. we have pretty dramatic numbers for methane because it's 84 times more. And we have a nitrous oxide like that. Seems very threatening, but let's look at the global GHG emissions in terms of those GVP. What do we have? If we look at the GVP 20 and recalculate all the global emissions, what we have here, 45% of global emissions comes from carbon dioxide. 9% of those comes from land utilization, forestry, and other things. Up to 40% comes from methane. So now we understand that one big part of global emissions is due to carbon dioxide, and another one is due to methane. So methane can compete with carbon dioxide. At the same time, on 100-year horizon, we have that 62% plus 11%, approximately 73% are caused by carbon dioxide, and 20% are caused by methane. So overall, we have that carbon dioxide and methane are the major global warming contributors, and methane takes the second place and even more harmful over 20-year horizon comparably to carbon dioxide. When I'm telling it's more powerful, more harmful, because its global warming potential is 84 times more, 84 times, and the amount of it is comparable to carbon dioxide. So we have a real big problem with carbon dioxide and methane that we need to address in our actions. Let's move next. At the same time, yeah, what about the nitrous dioxide, you probably might be interested in? Its potential is even more than for methane, right? 200 something. But if you can see, if you will see at those charts, there is only 4% and 5% respectively of nitrous oxide composition in the global emissions. So it's not a big part, and nitrous dioxide is not a big pollutant for our Earth in terms of heating. Okay, so now we understand what are those gases. We understand that they vary by their power. And now the second logical question is, how can we calculate them? If I would like to track something, I probably should account it. So what is the accounting metrics? How can I just, for example, I have a plant, I have a crude oil production plant. How can I calculate my carbon dioxide emissions? And this is a very interesting thing that has developed in the world. Maybe you have heard about this on previous lectures. There are 1, 2, and 3 scopes emissions that actually split all the sources of emissions by 3 big categories. The first category is direct company activity. This is the thing that we are doing directly. The second one is indirect activity, probably that, but we own those emission sources. The third thing is indirect activities, but we do not own it. So it relates to downstream activities. What does it mean? Let's take a look at this. Scope number 1 emissions. This is direct things that our company emits to the atmosphere. For example, imagine we'll speak about the company that extracts oil from the earth, that sells this oil to another things, or a metallurgical company. Let's talk about the company that actually produce coal. So we have the big pits with coal chunks inside. We have excavators that grab this coal. We have the production line. We have the clients everywhere. We're extracting coal. What is our scope 1 emissions? Scope 1 emissions might be divided into 4 categories. The first one is stationary combustion. So the heating source of our company. For example, we would like to have an atmosphere of our plant of 20 degrees, then we need to burn some coal that we extract to make some heat. Another thing is Another thing is company vehicles, right? This is the thing that we have. Our excavators, we have to fuel them and they emit carbon dioxide. This is the some vans that drive those coal. We also have the fugitive emissions. There is a very interesting thing when you excavate some coal. Coal usually it is usually located next to the natural gas volumes, and when you grab some coal, you might destroy this, like the reservoir for methane, and you have the fugitive emissions. So you grab some coal and the methane goes away. This is also direct emissions of your production facilities. And you also have the processing. Processing is the thing that just eliminate from the coal during your procession. Okay, we have the scope 1 and we are fully responsible on it. Then we have scope number 2, and it falls into a lot of, not so much really activities, but a couple of them, and we own those source of emissions. This is greenhouse gas emissions released in the atmosphere from the consumption of our purchased electricity, our steam, our heat, our cooling. For example, if we need electricity for production facilities, we can burn the coal that we grab, or we can buy some electricity from the near, let's say, nuclear station. And this is a nuclear station produce some carbon dioxide, just a small amount, but produce. And for example, we are responsible for those amount of carbon dioxide that was emitted due to this electricity purchase. And we also have the scope number 3 emissions. Scope number 3 emissions related to downstream activities, and it covers the entire supply chain of our products. When we sell the products, when we distribute the products, when we maybe operate some leasing activities, you can see it here. For example, we purchased some goods and services. We have a transportation and distribution here. For example, we need some railway transport to sell our coal products. For example, from in the middle of Russia, we use these railroads to deliver the coal into the Southeast Asia, to Europe, to other countries, and we are responsible for those emissions associated with railroad exploitation. We also can, we also should be responsible for use of our sold products. For example, how people will use. Maybe they will not burn our coal, it will be just lay somewhere, I don't know why. Or some customers will actually fuel our coal, and then we are becoming more responsible for these carbon dioxide emissions. Scope 3 is a really big chunk of activities. It also covers investment, franchise operation, leased assets. Like, for example, if I cannot buy something big, ship, for example, right? I can lease it from the big companies, like to rent it for a pretty long amount of time. And scope 3 is a really crucial thing for companies without like heavy manufacturing activities. For example, imagine banking, right? We have a bank somewhere in Jakarta. They don't have any pits, they don't have excavators. They probably do not consume a lot of electricity to fuel all its branches, but they have a lot of utilization of electricity. They probably have some franchisees, and they are responsible for their investments because they can invest some money in carbon neutral projects like solar stations, or they can invest those money into coal station, and it will also impact their balance sheet of scope emissions. On the right hand, this is pretty, I would say, difficult aspect. There are a lot of information on it on the web. You can just easily search it to better understand what those scope of emissions mean. So to sum up, the first scope is direct, that we are fully responsible for. The second one is indirect from our activities. So we don't directly influence to it, but we are responsible for it, and it relate to energy consumption. And the third scope, this is all indirect activities associated with our products that we sell, how customers use it, how we transport it, and other things. As an example, the company used to disclose their scope 1, 2, and 3 emissions. And on the right-hand side, you can see the example of Rio Tinto annual report that where they disclosed how many metric tons of carbon dioxide they emit. For example, in scope 3 emissions, you have up to 15 rows, right? They purchased goods and services, and it emits 6.5 million tons. What else they have? They have a huge amount of activities. For example, processing of salt products, right? Their customers do some manipulation and operations with their iron ore, and it causes a lot of emissions, etc., etc. So this is how the things works. Any questions on this?
Not yet.
Okay. Now let's look at more easy graph. This is the global greenhouse gas emissions by sector. Probably you see the dominant majority of carbon dioxide emissions come from energy sector, which involves production, transportation, utilization of energy, and the last majority comes from agriculture, forestry, and land use. When we grow some crops, when we have livestock and manure and other things. Yeah, so what we can also conclude from this things is that energy sector is a real big problem for the world, and it probably due to one reason, because energy sector fuel a lot of fossil fuels like coal, like crude oil, and that emits carbon dioxide. This is why energy sector is pretty carbon intensive one, because energy use in industry, for example, what we have here, we have iron ore and steel. This is like due to the chemistry of processes, we use a lot of electricity to melt iron, to produce it, to produce steel, and we need those cheap energy that we can use from coal, from crude oil products, because you're probably the energy of renewable stations, for example, in Russia, are not sufficient to produce a lot of tons of steel or aluminum. We also have the chemicals. We have food and tobacco, other industries that are pretty energy intensive. Another big chunk here is road transport. Road transport is our cars, and we fuel our cars with gasoline, which emits a lot of carbon dioxide. And as you can see, road transport is, I would say, the biggest contributor to the global emissions. If you split it into more groups, the road transport is the most powerful one, because completely every people tends to have a car, and it used to be a cheap car, because we don't really, not every person can afford buying a Tesla or some other things, and we now use the more appropriate options for us and buy internal combustion engine cars that emits a lot of carbon dioxide. Also, a big chunk of carbon dioxide is energy using in buildings. We use some energy to fuel our buildings, to heat it, and other things. So I have a question for you guys before we study together. What areas will you prioritize to start decarbonization? Based on your assumptions, where would you start here to reduce global greenhouse gas emissions? Any ideas? I would probably start with the most powerful one, with transport sector, with energy sector, and we'll evaluate which one will give me the quick wins. Okay, now we're going to the next part about the business and decarbonization, how business interact with all decarbonization practices. Basically, we can split the carbon footprint of a business by three big groups: operation activities, all the things related to product, and organization of the company. What does it mean? What is an operation? Carbon dioxide and greenhouse gas emissions should come, and the majority of them come from operation of businesses, which is manufacturing, supply chain, energy and resources, and financing. Manufacturing is the activities associated with processing of goods and services. Supply chain is all the emissions that used to come from distribution of our goods and services. Like we grew some crops and we have a car and this car drive 1,000 kilometers emitting carbon dioxide. Then we have energy and resources to fuel our production. And a very interesting thing here is green financing. We actually can reduce our carbon dioxide via utilization green financing and financing the projects that either do not emit such a big amount of carbon dioxide or just even consume it, like reforestation activities. Then we have the product. This is another big source of carbon dioxide emission, and emissions comes from its design. We can implement circular design or ecological design. Like you said in the beginning of the lecture, we can use recyclable packages, or we can work with materials. We cannot use plastic, and we can use renewable sources. And to buy the shopper, for example, and we use this shopper for 5 years. Another interesting thing is labeling here. We can promote our products via eco-labeling. So if we really grow it in an ecological way, without using a lot of fertilizers, a lot of bad things, we can label our product as ecological one that do not impact environment so much. And we have thirdly the organization sphere here, which splits into corporate social responsibility. This is facilitation of nature treating culture within the company. A lot of companies last years becomes more responsible for the environment they influence in, like Rio Tinto, the large metallurgical company. They restore some areas that they polluted previously, and they help to grow trees. They help to develop local communities. And another movement here is offsetting, carbon offsetting and certificates. We actually can buy those certificates and invest in some projects, let's say in Africa or in reforestation, somewhere in Congo. Imagine that my company emits a lot of carbon dioxide and I want to reduce it, but don't have any ability to build solar station or to grow some forest in order to reduce my carbon dioxide. So I will invest my money in growing, let's say, growing forest somewhere in Africa, in Congo. And those forests will consume some carbon dioxide, and I would say, okay, let's say that they will consume my carbon dioxide because this is the atmosphere and everything is interrelated. This is in 2 words how offsetting works. What we have here, we have a brief group activity here. I would like to ask you guys to imagine as much initiatives as you can. Initiatives might be outside the suggested tree. So how can your business reduce your carbon footprint? Let's think about this. maybe we can change the fossil fuels from gasoline to biofuels in our cars. What else we can do? Just, I would split you in 2 groups in breakouts and give you, let's say, 10 minutes for this activity, or even let's do 5 minutes. 15 minutes too much, I think. Let's do 5 minutes and then we will discuss what we have. Okay? Does everything clear?
Yes.
Okay, I'm creating the breakout rooms. I hope everything will be good. See you in 5 minutes.
Guys, aku nggak tahu apa-apa.
Itu apa? Pertanyaannya tentang gimana bisnismu itu ngurangin carbon footprint. Kayak renewable energy atau
Ya kayak kamu Loli.
apa
Pakai
kok
pembangkit apa?
bukan apa sih ya, aku searching
Suruh apa tadi?
bisnis gimana bisnis itu bisa ngurangin carbon footprint
Bisnis.
ya, renewable energy apa, shifting to renewable energy paling ya. Siap lah, di notes aja.
Ini kelompok apa individu ya?
Kelompok.
Raw materials kayaknya bisa. Ya sih. Aku tak ke kamar mandi ya guys.
Hi guys, how is the progress?
We are still working on it.
Okay. Any ideas? Just write down them in the chat.
Oh, okay. So we imagine as the business owner, something like that.
Yep.
Okay.
Yeah, just a bit. I would suggest you to a bit theorize on how can you reduce your carbon footprint. Maybe in product, for example, in product, in design, we can in material, we can use organic materials instead of plastic, or we can use something like circular design, for example, modular mobile phones that can be, if you break something down, you just restore it with another part, not buying the whole new phone, something like that.
Okay, great.
Okay, I will join to another one.
Yeah. Okay.
Aduh.
Kamu nyari apa nih?
Aku tuh dapetnya cuman yang shifting conventional electricity itu loh ke renewable energy.
Oh,
Udah itu
aku
doang.
produk desain ya. Tapi kita
iya.
kayak ini loh, kayak
Halo?
graphic designer gitu. Ya, oh ada bagus.
Yes, ada bagus.
Sorry,
Help
ini aku
us.
hilang ya.
Help us, help us.
Aku luput.
It was growth without fertilizer utilization, something like that. It might not be the best, the perfect idea. It's just interesting to achieve as much as possible.
Okay.
Okay.
Let's spend 5 minutes on it, on this task, and then
Over here, I can see green financing. What does that mean?
green financing is when you can allocate your capital on projects that will actually reduce your carbon footprint. For example, you can use you can build a solar plant and do not burn the coal on your facility of production. Or you can, let's say, buy electric vehicles for your cars of your company, something like that.
Yeah, we can do like, we can calculate like our CO2 emissions.
No, you just brainstorm some ideas and that's all.
Yeah. So as a company, we can just, calculate our CO2 emissions, and equivalent to that, or maybe more than that, just like grow trees or something like that.
Yes,
Do
this is
plantation.
also a very good idea.
Yeah, near our campus, around our plant where we have production,
Mm-hmm.
that can help us.
Yes.
Yeah.
And I think for the production for carbon footprint, maybe in material for products,
Exactly. Yeah.
I
Nice
think
catch.
it's like, yeah, the first one that I've mentioned, that we using kavas,
Cassava.
cassava, yeah, sorry.
Cassava.
Cassava. We use cassava rather than using plastic, so it will not harmful for the environment.
Yeah, but
Yeah.
the price is still expensive, especially
Yeah, but
in
yeah,
Indonesia, unfortunately.
I think
it's kind of
if
expensive maybe for the
if
production.
we design our product with, like, we put an extra effort on designing, we could make our product or a production more efficient, thus reducing our carbon footprints in making the product itself.
Yeah.
Yeah.
Mm,
And what do you think about labeling of the products? What information could be useful?
I think for labeling we can make like if in Indonesia in the plastic bag they wait, I'll show you the plastic bag.
What is offsetting? Actually, in organizations, there's offsetting. What is offsetting means?
Well, offsetting is basically you can buy credits of carbon from other green companies. And basically you invest into the forest plantation or forest plantation, and that's how you would offset your carbon footprint of your company, by capturing carbon with the help of other companies.
Hello, guys. I hope you discussed a lot of things. It was a lot of activity in both groups, which is very happy. Wow.
Sorry.
No problem. Okay. So does anybody want to share some of those initiatives, activities that we might to implement?
So from our group, assume that we are a graphic designer.
Okay.
For printed design, we think that paper choices, ink, and also the material can significantly affect the carbon footprint of a design itself. This means that less emissions, and we need to be selective to our material to control our carbon footprint. And as a graphic designer, we work on a design for a client, and we will need to share the design with our client as well. So rather than emailing them our design, we could use like Google Drive for sharing and also collaborations. And what else? For image, I think that it's better for us if we have a website. It's better for us to use a colorful background with a white text rather than dark text with a white background. I think it can reduce our electricity usage.
Yeah.
That's all.
Okay.
Maybe my other member team can add something.
Thank you, Evelyn. It was a real, like, very detailed description. I like this. You think a lot of details. I appreciate that. What about the other group? Who will present? Okay, another group is on mute entirely, but I heard a lot of interesting initiatives from them in the breakout groups. Will anybody share your thoughts?
Oh yeah, I think we can do extra effort in designing our product, because I think if we make our design really good, we can really cut corners, and really make our product as efficient as possible, thus reducing our costs and also our carbon footprint in the process.
Okay. Yeah, that's a very nice catch. Thank you so much, guys. Okay, let's move a bit further. I think we'll make a 5 minutes break to have a bit of rest before starting value capture and threads. So I would see you in 5 minutes, and we'll continue. Nice time to
Okay.
grab some water and snacks. Okay, guys, I think we can slightly start. Is everybody joining?
Yes.
Okay, that's nice. So I would follow the next steps. Now we're going to discuss value capture and threats. So the question here is, okay, so now we understand that we need to decarbonize our business, to reduce our carbon footprint. What is the profit for business, right? Because the business organization used to have profit from their activities, their products they sell. It then don't. If I were a business owner, I would say, okay, I just don't want to lose my money from just being green, because it is very good for the environment, but I just don't want to lose my money just for free. Maybe I can gain another value, and now we would like to. I would suggest you to understand what does it mean in practice. So let's think about the potential threats. Maybe some disasters will cause if we will inactive. What might happen? Imagine I am a business owner. I would say, okay, the option number one is just doing nothing. If I will not do nothing with my business, probably it will not cause me any money losses. So I don't need to spend it on green financial projects, on building renewable energy sources, to buy energy from renewable stations. I will not also need to decarbonize my carbon footprint. So maybe being inactive is a good choice, but it's not really, because the potential threats are tremendous. If we will not act as a business society, as a human being, our Earth will tend to be not so good place to live. This is why. So actually, there are four main impact areas of global warming: environmental, social, and economical one. What will happen if we will not decarbonize and we will do business as usual without like dirty business with a lot of carbon dioxide emissions? First of all, it will disrupt the biodiversity. We might face a risk of loss of endemic species like Sumatran tiger, like polar bears, because the ice is melting and the territory for their existence is shrinking. We also will face some disease outbreak like COVID. It was one research in even a Nature paper, as I remember, when it was a clear and concise logic that shrinking the amount of forest territories might lead us to new diseases outbreak, because we don't have really established ecosystems, and a lot of mosquitoes, a lot of insects might come to those territories, and due to the heating, they might produce some new diseases that we have never experienced. And also the viruses might appear on those territories. Then the food system disruption. Food system is basically the shrinkage of food mass due to dry climate, due to loss of water somewhere. Imagine rice fields in China and in Japan will degrade. So who will feed the world with rice? We also will face disruption of food system, because we might expect very difficult logistics from region to region in sea, like it was this year with one big ship. We also will face a huge physical risk to real areas and assets. We'll lose areas suitable for life due to the dry and hot weather. We'll experience some swamping, deserting, floods. We'll experience more weather cataclysms. For example, business might face these huge physical risks, like it was last year when it was the huge oil spill in the middle of Russia at Norilsk Nickel. What was the cause? The cause was that permafrost melts and the soil become more soft. So some of the constructions breaks down on this soft earth, and it causes the crude oil spill. And we'll face more and more physical risks. And on some estimations, the physical risks might cost us up to 13% of global GDP, which is a huge number. Imagine like every $10, every other $10 you will just spend to mitigate those climate risks. This is insane. Then we'll face social threats like climate migrations. It will influence on geopolitical instability, new terrorism risks, new attacks, new cultural conflicts. We'll also observe inequality rise, right? Because some people will live in more suitable parts of Earth, some in less suitable parts, and they will like compete with each other. Why should I live in this very dry area while some people can live in the north, let's say in Norway, in pretty good climate? I would like to move to them, and it will raise some inequality. Then we'll meet probably economical risks. World GDP, as I said, will experience more dramatic split on developed and prosperous world and climate suffered world. Due to it will be in economical aspects, it will be in human potential, and this is really bad for us. And we also will experience some cities disruption because by the end of approximately by the middle of the century, by 2050, more than 70% of people will be hosted at cities, which create as well physical risk, diseases risk, and cause the huge labor shift, right? So the people will leave agricultural dominions, they will move in cities. So, and here where urban planning will be vital for human lives and economical stability. And by the moment, not every city is ready to inflow of new citizens, because it will disrupt the city infrastructure, city like economy and other things. This is the threats if we will not be active and will not doing anything. And I would suggest you guys to prioritize what might be the potential opportunities in your spare time. What you will receive those slides and you can think about it. What might be the opportunities for my business, for people, for governments, if we'll face those actions boldly? Okay, any questions so far? All right, so now we start our the last part of the lecture, and we'll briefly look at some carbon abatement technologies that are currently existing in the world and helping us fighting with these climate changes and greenhouse gas emissions. First of all, let's speak about renewable energy. This is the very interesting thing when you shift the global consumption of fossil fuels and replace it with renewable sources. And renewable sources here are sources that probably might be restored within the people's life. For example, sun, we have the constant sunlight, approximately half of the day. Wind, we have some wind regions, we have water regions, and water does not disrupt this water within the processes, but we just use its power. And we also have the earth. There are some earth stations. What is the difference between the fossil fuels? Well, some people might say that fossil fuels are renewable as well, and this is true partially, but they are renewable on a large scale time horizon. For example, some storages of oil, of coal might be restored, but within millions of years. Probably it's not the good case for such a dramatic increase of world population, and we need some more restorable sources. That is why how companies interact with these renewable sources. They basically can buy energy from renewable suppliers or build renewable facilities on their own production site. Let's closely speak about each of them. About the solar panels. How does it work? Basically, you have the solar panel here. Just 1 second. Yeah, you have the solar panel here. The sunlight goes here. Then inside the panel, there are pretty complex multi-layer panels based on silicon, based on other materials, and due to some physical and chemical processes, it gives us electricity, and then electricity goes throughout the converters, inverters, and go to the end customers. This is like basically how does it work. The most abundant technology right now is silicon-based, with relatively inexpensive cost of implementation, but average efficiency. There are also some more efficient technologies that are implementing in space, because we need very light devices with low mass, low weight, and big efficiency. But they are really costly. They cost a lot. It's very difficult to produce them for the large scale. So this is why the world is stopped on silicon based. But there are some emerging technologies like perovskite based, like other silicon modification technologies. And at the same time, the utilization is pretty immature. So the life cycle of this panel might be up to 20 years, but they might be broken easily. And then we need to restore it somehow. How does it work? No one will have a good answer, because we don't have like utilization facilities. We don't have the plants that grab all the solar panels and extract the silicon from it. What else? We have the wind power. Wind might be onshore, it might be offshore, somewhere in the ocean. This is pretty promising technology, complex system that working like a windmill. So basically, wind is blowing, rotate these big propellers that produce energy while they are rotating. But this is very there are a lot of like threats, I would say, not big risk, but threats. Might be maybe in the more long-term perspective, it will change a wind flow somehow, and wind flow will cause some clouds, some weather will not be removed from one territory, but will stay for a long time. So yeah, some risks are also associated. And also the big question with recycling, because it's not, we need to restore it, we need to utilize it better, and there is no clear like value chain for their utilization. Another one interesting thing is water energy. How can we use it? We have actually a lot of types, but the most common one is hydropower stations, which actually, you see the difference of level, of water level. The water from the upper source flows throughout the system of turbines, and falling water rotates those turbines, producing electricity. Pretty simple. Pretty effective, comparing to even with coal stations. And but the thing is that it's very bounded to the location, right? So it is very abundant in China, in Russia, in the United States, but it not can be probably implemented in let's say in Indonesia, because I would assume that you don't have a lot of might be wrong, but my assumption is that you don't have a lot of like rivers, so hydropower stations will not be very cost efficient to build it. And also there is a big risk of biodiversity loss, because imagine the fish that are existing here. If fish will go here, it will die, and we can lose a lot of species, a lot of animals, a lot of plants. So we need to move out the fishes from here to some natural restorations, to another rivers, and that additional stripes of river might create swamping of territories and other things. Another type of water station is tidal stations. When the sea level increase and decrease within the year, within the day, it rotates also the turbines which produce electricity, but it's pretty time-bounded technology, and it is very specific for location, for territory. For example, in Norway, there are some tidal stations when we have the pretty strong tidal movements. It might be used. Another one is geothermal geological energy. This is all the things that we come from our Earth. One source is geothermal stations, like in Iceland. It produces electricity from the natural heat of the land, but also have then very narrow local location span. Another source of energy is biomass, and biomass is all the things that actually grows on the earth that we can use, that we used to think is a waste. We can just use this wastes for producing energy. And there are also cases in Oslo. The people use biomass to fuel the local transport. So you eat something on your dinner and you have some wastes. You throw it into the in the trash can, then special one, and then the civil workers collect all these trash cans and throw it into the let's say to the bus, and bus produce this into the energy. Sounds amazing, but you need real detailed system to produce it. System of grabbing the wastes. What is the future of this renewable energy? There are a lot of forecasts, a lot of predictions, but overall they are pretty similar in the thing that the world will experience a reduction of oil and coal by some years, and there is a rapid scenario, net zero scenario, and business as usual. Business as usual is attributed to the thing if we will not do anything. So we will consume a lot of energy, a lot of carbon dioxide emissions, and we actually now we are understood that this is not the way that we're going that we would like to follow. So what are the trajectories? We will reduce natural oil usage, coal usage. The nuclear stations will probably grow, as well as hydro, and the most growing sector will be the renewable sources. So business need a huge steps toward renewable source development in order to reduce its carbon footprint. Government support is really crucial here to establish the initial investment for its development, and also financial institutions should play its roles in helping to develop those projects. All right. One is the first technology. The second one is probably the hypest one is hydrogen. Hydrogen can be extracted from variety of sources and you can produce energy from hydrogen, which tends to present as a very clear one. Let's look at this in more details to understand why is it so. First of all, hydrogen can be extracted from a variety of sources, from fossil fuels, from biomass, from water, via electrolysis, from natural gas and other things. And there are a terminology like blue hydrogen that is produced from water. There is gray hydrogen that is produced from the natural gas. And so classification of natural sources exist. Then, so natural gas right now is the primary source of hydrogen. And okay, so we gain those hydrogen. So how does it work? There is a hydrogen fuel cell on the screen. You basically, the hydrogen is going into one part of it, then it splits onto hydrogen plus atom ions that move throughout the membrane and combine with oxygen ion, which is coming from air. You have some oxygen from air, which is splitting into the ions, and you have H2O, which is water. So on the outside, you have electricity and you have water vapor. Sounds really good, because you don't have any carbon dioxide emissions, not so much. You don't have any other bad gases emissions, but you have water. And water, as you remember, is also greenhouse gas. So this technology might create a threat that it will be a lot of water vapor. And this is a very open question for every scientific community, because there are a big debates on whether water is disposable, or maybe this water vapor just condensate into the water and does not affect us somehow. A lot of questions. As well, also the hydrogen technologies right now is pretty immature because it requires a lot of energy to obtain hydrogen, to store hydrogen, and to create. And there is no mature infrastructure for hydrogen power stations. The next technology that I would like to describe you is electric vehicles and alternative fuels. Electric vehicle is basically, imagine Tesla. This is the regular car, but working from electricity with lithium battery inside. Pretty good technology. It is developing. The cost parity will be achieved by 2025 approximately. And a lot of European countries have already abandoned internal combustion engine cars, so the regular gasoline cars, from entering some capital cities like Paris. They are restricting some zones of entrance for those cars. At the same time, European government produced some financial help for people willing to buy those electric vehicle cars. And there are a lot of researches showing that the electric vehicle car is pretty good. You can see it is split by year, by location. Overall, you see that the carbon footprint from battery electric vehicle is less, completely from 2 to 3 times from the internal combustion engine cars, right? And the majority of emissions comes from electricity production and from vehicle manufacturing, while the maintenance and the fuel consumption completely equals to zero, respectively, with internal combustion engine car. What does it mean? That the world is going to shift for those electric vehicle cars, but again, it uses not restorable source of lithium, source in metal lithium, because lithium is used for batteries. And basically right now it works like that. So you create this car and then you just throw it away. When you're throwing the car, you have a lot of aluminum scrap that can be restored, that can be recycled into something new. You also have some lithium batteries that looking something like that, right? You just throw it away with a lot of lithium inside that can be actually restored and to come back to this chain. So this is only 5% of lithium batteries in the world right now are recycling. Another part is just throwing away. Another interesting technology is simply carbon capture, utilization, and storage. And there are two ways of working. First of all, you can capture the carbon from the air. You can just imagine the vacuum cleaner, just the huge, large-scale vacuum cleaner that soaks that sucks the air and extract carbon dioxide from it. Pretty, I would say it's not very efficiently, because the amount of carbon inside the air is increasing, is small. So you have to pump in, to suck in a lot of air to gain some carbon dioxide from it. That is why another way of reduction is just capture the carbon emissions from industrial processes. For example, when you produce the cement for a building, for construction materials, there are a lot of carbon dioxide emissions due to the chemistry of the process. So you can basically capture those emitted carbon dioxide and then work with it. Then what's happening? When you capture the carbon, there are a lot of carbon capturing technologies like membranes, chemical absorption by surface, by liquid, and other things. You capture those carbon in a variety of forms. For example, some calcium carbonate or other carbonates. There is an like the calcium carbonate. You can work with it next. So basically, you can just put it into the earth in form of carbonates, in form of just compressed carbon dioxide. So imagine you have the underground storage, underground tank, under like the depth of 1 kilometer under the Earth's surface, and you have the carbon dioxide here. That's it. Or another option is to use this carbon dioxide to produce something new. What can be those new things? There is a lot of research in this area right now, and you can actually use carbon dioxide to fuel. There is the carbon dioxide to polyols, to and other things, and you actually can gain, as I remember, some biofuels from this carbon dioxide, which is pretty amazing opportunity, I would say. Okay. So you can gain additional value via carbon capture, utilization, and storage. And there is a big area for chemical R&D activities. But at the same time, implementation costs are relatively high right now, and commercial benefits are unclear. So if I just will pump it into the earth crust, what is the benefit for my business? I don't know. And there are also another big trends that can be described in a more like brief way. There are agricultural and alternative food practices, which means that there are like some facts that existing food growth practices seems unable to feed quickly growing world population, and will not be able to feed more than 10 billion of people approximately, due to some, based on some researches. So we need new agricultural practices like genetics, like new growing methods, using less amount of water, using less lands, or making it more effective. We also have another big levers here is low protein diet, since it will reduce carbon dioxide emissions from meat production. As you remember, the methane is associated with 40% of global greenhouse gas emissions, and surprisingly, probably the biggest source of methane emissions is cows. So when people grow cows for cattle, for beef production, cows produce a lot of carbon, a lot of methane during their life cycle, due to their organism's specialities, and those carbon dioxide and those methane is fugitive, and it creates a big part of global warming. The next technology that we have here is nuclear power. There are big debates on whether it's renewable, whether it's green, whether it's not green, but overall, if managed properly, and this is the key key phrase here. If managed properly, nuclear power presents the vast opportunity for clean and cheap energy production, because you have a real big amount of uranium inside the Earth's crust. You have pretty mature recycling activities for these radioactive materials. So you can produce cheap and affordable, clean at the same time energy. Another option is reforestation activities. And the reforestation is basically planting the trees, planting the specific types of trees to make the world better, to restore some lands from tree cutting, from forest fires. And urgent reforestation activities are required to maintain the optimum balance right now, because we experience the increasing temperature, which destroys our forests, and forests are the natural like sponges, natural sponges for in Earth, because it's absorb carbon dioxide while it's lifetime. So we need to plant more trees to maintain them. It will double help absorbing the carbon dioxide and producing some more tree and wood for us. So it was the brief overview of the things that are playing on the global arena right now. There are also some smaller technologies, but I would not deep dive in those because they are pretty interesting, but this is pretty local history. Overall, today we understood with you, so what is global warming? What is it caused by? What are the main sources of those emissions, scope 1, scope 2, scope 3, from the business operations? And what are the levers, what are the technological levers to reduce those emissions? And one more message that I would like to leave you with is that technological levers is good, but we need to change our perception of the thing that things should going for. We need to think like in a more nurture way about our planet, not to use a lot of resources, not to waste just water when you are brushing your teeth and other things, because all the changes starts with us, and all the big changes starts with just the small actions. This is all the things that I would like to tell you with today. Thank you so much for your attention. In case of questions, you can reach me out via WhatsApp or my email. Yep, this is the end of the lecture. Thank you so much. I hope it was very interesting for you and intensive as well. And see you on next lecture.
Thank you, Roman.
Thank you.
Thank you.
Thank you.
Thank you.
And I wish you
Thank
everybody
you.
a good day. Hope you will spend it with helpfully. So bye.
Same to you. Bye.